like, subscribe, press the bell icon for more updates. For more videos, download our app from Play Store. Faculty Diploma Program. Welcome to third session of Machine Learning and Data Science using Python.
Good morning all. My name is Ankita. It is my pleasure to extend a warm welcome to all the respected professors and teachers on behalf of PHN Technology Private Limited. Thank you for joining us today for the third session of this faculty diploma program on topic of data science and machine learning with Python. As you all know, technology is evolving at a rapid pace, and we at PHN Technology Private Limited are committed to staying ahead to curve and providing innovative solutions to our clients. For today's session, we have Mr. Uday Zope with us. So Mr. Uday is a data scientist with over 4 years of experience in the field of data science, including both academic and professional career. Uday has been working on computer vision product for the last year, which is specifically designed to aid MSMEs controlling the manufacturing process smoothly. Now I'm handing over this session to Mr. Uday.
Hello. Good morning to all.
Are you ready?
Yes, hello. I'm audible?
Yes.
Okay. Hello, everyone, and good morning to all. So, due to some medical issue, I wasn't able to attend the class session, but colleague of mine conducted that session. So we'll do some recap that what we have covered already in first two sessions and what we'll be doing in this third session now. So in first session, we introduced basic concept of machine learning, including definition, what types of machine learnings are there, basic ML workflow we discussed, and then what kind of tools we are going to use throughout this course or throughout this session. And another thing, we did some minimal installation. Some of you are going to use Google Colab, some of you are going to use Jupyter on local server using Anaconda. That kind of setup we already done. As I have information in last session, the colleague of mine covered basic fundamentals of Python, then basics of a library like pandas and numpy, and then he also explained some sort of explanatory data analysis. So what we are going to do, we have now basic idea of all the libraries that we are going to use in the machine learning. So in today's session, we are going to cover two very basic algorithms, which comes under the supervised learning, and one will be a regression problem and one is classification problem. So a regression problem we are going to cover using algorithm called linear regression. Then we'll move to a logistic regression, which will be a classification problem. We'll perform a very basic binary classification, and then we'll do a multi-class classification using logistic regression. You don't have to worry about EDA. We will do a very basic experimental data analysis as well. We are going to use extensively NumPy and Pandas library throughout this session. This session will be theory plus coding. So I'm considering that everybody have completed their setup and installed all the libraries required for this course. I'll be giving you some data sets which you have to upload on your Google Drive, or if you know how to download data sets. So I'll also guide you through that. So we will start with everything with this session. So I'll explain. We'll start with linear regression first. Okay. So now just let me share. Okay, I hope my screen is visible. And
yes.
Okay, thank you. So we'll start with linear regression first. Now, So what we are going to do, we will understand what is regression. Then I'll explain the mathematics behind a linear regression. What kind of equations are implied behind this technique. We'll see the application of it, and then we'll see what kind of types are available are there, and the important terminologies involved in this particular topic. Then we are going to implement this linear regression using scikit-learn libraries and Python, and perform some data analytics and exploratory data analysis on some data set that I'm going to explain. I'm going to provide you. So we'll start with the basic. What is a regression? Okay. So regression is a basically technique of analysis, and it's a statistical method used to examine a relationship between dependent variable and independent variable. Now, what is dependent variable and independent variable? So basically, if you consider a graph like this, okay, and sorry, so dependent variable is something. For example, if your company asks you
Sir, you are not audible.
might be profit through okay. So this is what dependent variable and independent variable. Now, hello, am I audible?
Yes, now you are audible.
Okay, and this is dependent variable. Now, what is a linear regression now? So basically, the regression. So before moving to a linear regression, we will see where we use this regressions analysis. So regression analysis is commonly used to predict the value of dependent variable based on value of independent variable. I have already explained you what are the dependent and independent variables through the example of annual sales. And then it is often used in the field of finance, economics. For example, you have to predict the value of certain stock, and you have a historical data of that stock value or that particular share. Then you can use a linear regression to predict a certain time frame, in certain time what will the value of that particular stock. This kind of applications where linear regression is applicable. Then obviously there are number of types of regressions are available. There is a including linear regression is there, multiple linear regression is there, logistic regression is there, polynomial regression is there. Now linear regression is one of the most common used algorithms available in machine learning, and it is very intuitive, and it is very go-to algorithm when somebody is starting to learn intuitive machine learning. So that's why we are starting with linear regression and logistic regression. So now we use this regression analysis for we use regression analysis for application of linear. Do not worry about these notes and everything. I have already built a Jupyter notebook where I have whatever topics I'm going to cover, the theory and code, everything will be covered. I'm going to share those notebooks with you after the session. So the applications will be uh, prediction. So prediction is what? So regression analysis can be used to predict value of dependent variable using the value of independent variable. For example, it can be used to predict the sales revenue based on advertising spending, or predict probability of patient developing a certain disease uh, based on their age, gender, or other factors. Then there is a trend analysis. Okay, trend analysis. where we can perform a regression analysis, which can help us to examine the trend in a state of data over a time. There is a concept in ML, we call it a time series data. We will cover one case study with time series data as well, so you'll understand what is the trend analysis. Then forecasting, for example, uh, uh, there are certain house pricing is available in certain area. For example, we take a city Mumbai. Now house pricing in Mumbai depend on certain factors. Now house pricing will be a dependent variable. House price is a dependent variable, and what will be the independent variable? What is the distance of that particular house from the coastal area, and whether that area is available in metropolitan or outside outskirt of the city. So these variables are going to impact, or their correlation with the dependent variable is going to impact the outcome of the price. Like if the house distance from the coastal area is very less, or it's considered it's less than 1 hour drive, then the price of the house is going to be a high. If it's outskirt of the city, then price of the house is relatively lower than compared to a house near to the coastal area. So this kind of applications where regression is used. Now, what is linear regression? So, as we have understood dependent variable, so we'll understand what is linear regression. Now, linear regression is basically applicable on the continuous variable. Now, what is continuous variable? Continuous variables are the variables which are which are usually in the form of numerics. For example, I explain you an example of house prices, where house prices will always be a numerical value. Now, whatever independence variable I had, for example, distance from the coastal area, whether the location of house is outskirt or in pretty posh area. So these are the variables which are going to put an impact on the outcome of the variable. So now, just so this price of the house is a numerical variable, and it is continuous numerical variable which will always be in the form of some numerical value. So this is where a linear regression is applicable. Now it is one of the most popular machine learning algorithm, and it is a statistical method which is used for predictive analysis. Now, as I already told you, it makes a prediction on continuous or real numeric values, such as, for example, if you can say we can predict a salary, then sales, then age of the particular person, then product prices. Uh, these are the dependent variables. Uh, I hope you understand what is the definition of dependent variable. Now, what is the what exactly linear regression do? So consider this graph. Now I'm going to put a short form instead of writing everything. DV will stand for dependent variable, and IV will stand for independent variable. This is our x-axis. This is sorry. This is our y-axis. Okay. So now, and these are our data points. So these are our data points. Now, if you can observe these data points are in linear fashion. Linear fashion in the sense that they are moving in a one direction. So for example, if we want, let's draw a line. Okay, let's draw a line. Okay. So this we call it, it's a line of regression. You can say it's a line of regression, and these dots or these points, these are data points. Okay. Now, in linear regression, what you exactly do? You have to model a relationship between your independent variable and dependent variable by using regression. when the outcome or output which you have expected is in numeric nature. Now, how you build this relationship? So there is a um, how you build this relationship. So if you guys must be familiar with this equation, y is equal to mx plus c. Okay, so this is an equation of, if you are familiar with the linear equation and equation of lines, so this equation defines, it's an equation of a line. This is an equation of line where m, sorry, where m is slope of a line, m is a slope of a line, and c is an intercept. Okay, and x is our independent variable and y is the dependent variable. Okay. Now, if we want to represent this particular equation in the form of machine learning, which is very close to machine learning, how we are going to put that equation? So we will do what we'll do. We have I'm going to use certain notation that I'm going to explain you step by step. So what we'll do alpha 0 plus alpha 1 into x1. Okay. Now you must be confused that what is this alpha 0 plus alpha 1 and what is x1. So forget about alpha 1 and alpha 0 and alpha 1. Let's understand this first in this equation. This x1 is a independent variable, that is we already understood. Y is a dependent variable. Now this is an equation. So this entire equation is related, or it defines a single linear equation where there is a single independent variable available. That's why it's called a single. This is single linear equation. So if there is single linear equation, so there will be a multiple linear equation. So it's the same, just equation changes, where instead of having a single variable, instead of having single independent variable, we will be having a multiple independent variable. So I'm going to explain that equation as well. So this is so multiple linear equation. Now, please bear with me. I'm going to explain what is alpha and everything. Let me write this equation first. So what you have right now, the equation is your dependent variable is equal to your alpha, your alpha 0 plus your alpha 1, your x1 plus your alpha 2, x2 up to your alpha n xn. So this is your equation for a multiple linear equation. So multiple linear equation is something like, you have, instead of having one independent variable, you will have multiple independent variable. For example, in your annual sales example, you have profit loss and number of products you have launched throughout the years. So that was your example for multiple linear equation. So now we have understood this entire equation. Now what is this alpha value, and from where this alpha value is generated? So we have certain, well, if you understand the concept of correlation in statistics, a correlation is a terminology where you have to define a relation between two variables, and how the correlation factor, which is our alpha, will be defining how important that particular weight of that relation, weight of that correlation. This is our alpha vector will define. So let's take an example, and I'm going to explain you through example what is this entire alpha value and everything. So what I'll do, I'll put random values in our equation now. So with example, you will understand what I'm trying to say. So y is equal to let's say 0.9 x1 plus 1.2 x1 plus 2x2 plus 4x3 plus 1x4. So this is an equation. Now your x3, x4, x2, x1, x1, these are your independent variables. Now what is this value 0.9, 1.2? So 0.9 is an value. So this value defines that. Now what is the minimum value and maximum? Minimum value is 0.9, maximum value is 4 here with respect to x. Now this value defines the weightage of your correlation, that how well your independent variable is correlated to your dependent variable. Or you can say that like what is the importance, or what is the how much weightage this particular variable have for predicting your outcome or dependent variable. Let's say an example. For example, we do have let's take an example. We have, for example, we have to predict whether a student failed or passed. So we have ID number of students, we have percentage, and we have our outcome, pass or fail. Okay. So now basically you can basically understand that if we have to predict whether the student is pass or fail, we can definitely predict it from the percentage. So here the weightage of this percentage, this independent variable, is obviously very high. So which will be certain value, consider it's 9. If 10 is the maximum, it's 9. Uh, and this year percentage is x1. So this 9 number is defining importance of your x1 for your outcome. Now, what is the role of your ID in this particular? What is the role of your ID in this particular example? Whether you put ID or if there is no ID, it does not going to make any difference on your outcome. So what will be the correlation or coefficient of this particular? What will be the alpha value for this particular ID? It will be somewhere around 0.0001, because it's not going to make, it's not making any sort of very big impact on our outcome. So this is what basically your alpha value is. Okay. So now this is a very basic and intuitive understanding of your linear regression. And yes, so what we'll do now, that we have understood this basic mathematics and basic what linear regression is actually, that we have to, if you haven't understood right now, you'll understood everything when now we are going to implement everything right now. So I want everyone to open your Google Colab or your Jupyter notebook. So we are going to use Python and some open source data set available. We are going to perform basic EDA and we will implement linear regression now. I'm going to share all the notes of whatever I have explained to you after the session. So yes, I hope this screen is visible now.
Sir, it is visible.
Okay. So now what you have to do now is, everybody know how to create an Jupyter notebook. So now what I so I'll share one link with you guys so you can download a data set from there. Because I think I'm not able to share this data in so
So you can share it in chat box if you want to share any file.
but they are asking me Google they are not allowing from local from the they want me to screen is not visible. Everybody is still saying let me try that. So what you have to do, I'll share a link of an data set and you have to download that data set from that particular. So I take a link now. I'm going to share that in chat. So this is a website called Kaggle. Just a minute. So now you have whatever link I have shared. So you have to go on this website and you have to sign up, I think, with Google account. And here you have to download data set. I hope this Kaggle screen is visible. Is it visible? Hello.
Yes, yes.
Okay. So you have to download this data set and then you can extract this data set here and you'll find a file something like housing. So people who are using Google Colab need to upload this file on your Google Drive. So have you got a data set? Can you please give me a reply on chat? Or are you able to download data set or not? Is this link? I think link is available. Registration process taking time. Okay. Sorry, I cannot. I'm not able to share this file. Otherwise, I would have shared here. Let me do one thing. I'll give you public access to my Google Drive. So I think it will be easy for you to download. I have already put it on Google Drive. Just a minute. So this is a Google Drive link from where you can just clone this data set in your Google Drive.
Hello, sir.
Hello.
So, is this the software that we need to download?
No, what you are using, what ID you are using right now, like Google Colab or Jupyter Notebook. If you are if you are not aware about this software or this setup, then I think um, in first session we covered how to do a entire setup things and installation. Is everybody able to access this Google Drive link?
Yes, I didn't attend that session. I couldn't
Okay,
attend.
okay. You'll get. I think we'll ask everyone to get a recording of that session. Okay.
Yes, we will provide it.
Okay. Okay. Now everybody is able to see this. I hope everyone got access to this Google Drive. So what you have to do now? You have to write a code. This code that you have to mount your Google Drive first. Or simply what you can do, if you are using if you guys are using Google Colab, then only this applicable. Otherwise, what you can do, you can download all those data sets or that PHN dataset folder in your local computer, and we will use that in local server. So what you can do after putting everything in your Google Drive, I hope everybody's cloned that particular data set in their Google Drive. So once you executed this cell, so you will get an access of your Google Drive here on the left side. You can where you have this drive, go to my drive, then find PHN dataset folder. Okay, in PHN dataset, you have to click on this three dots where housing.csv is there, and you have to copy the path and write this code import pandas as PD, and then you have to read that CSV file here. You have to put that path here, then you will able to execute the code something like this. And if you have completed this, then you have loaded dataset successfully. So these are the very basic first three steps we need to do. Then we'll start with the okay, for Jupyter Notebook, just a minute. Have you downloaded dataset in your local computer? Okay, so if you have downloaded the data, let me share that screen. Okay, now this screen is visible. So if you have downloaded, so please create a Jupyter Notebook or start your session or start your Jupyter Notebook session from the folder where you have kept the dataset. So if you can see here, you can see these two datasets are available, housing CSV and iris CSV, in my folder where my Jupyter notebooks are available. So basically what you can do import pandas as PD, execute the cell, then data is equal to PD dot read underscore CSV double inverted comma, then pass the name of the housing.csv here file, and if it's successfully loaded or not, you can check by using data.head attribute, and you can use the control plus enter to execute cell. Now this data is successfully loaded. So I hope everybody till here everyone is clear now. People who are using Jupyter Notebook. Okay. Okay. So anyway, most of you are using Jupyter Notebook. Oh, sorry. Most of you are using Google Colab. So I think I'm going to prefer Google Colab. Or I'm not able to understand how many of you using Google Colab or Jupyter Notebook. So both, once you loaded the data, everything will be same. Okay. Okay, now we'll start with this linear regression. So before starting, we have to import certain important libraries. You have understood what is a pandas, why we use pandas in your last session. Then there is a one more library we are going to use is NumPy. Hello, Ankita. Is the screen is visible?
Yes, yes, it's visible.
Dual screen is visible or single screen is visible?
Single screen, sir.
Okay. Okay. Thank you. So these are the libraries. NumPy is the NP. I want everyone to type, divide your screen into two parts. Put this Zoom video link on the half section and put your Jupyter notebook in the half section. So I want everybody to write the code as I'm writing the code. So you'll get a hands-on experience and you will understand what we are doing actually. Sorry. So this is one. Then we have to plot something. We have to plot. We have to understand data set. We have to perform very small explanatory data analysis. We might going to. We are going to plot. So we have to use the matplotlib. These are the predefined libraries. You just have to understand, or you just have to learn how we have to use. If you are getting error, then you haven't installed this library. So if you are facing some error, please let me know. I'll put some commands in chat box again, so you will be able to install. There's one more library we are going to use for plotting. It's cbomb and SNS. And we use one magic function for warning. Matplot. So before moving to the next section, what we have to understand first, what we are going to do. So what is this housing data set? So basically this housing data set is an uh, data set where certain variable, independent variables are there. For example, longitude is there, latitude is there, housing age is there, number of rooms in a house, total bedroom in a house, then population of that area, then number of household, then income of the family, then median house value, and then ocean proximity. Ocean proximity is something which how far the house is from the coastal area. So these are the variables. Hello. Okay.
Yes,
So
yes.
these are the variables. So what we have to do is now, by examining all these variables, we have to identify what first we have to identify what we are going to do. What we'll do, we will identify or we will predict the value of house. If you are able to see this median house value column here, so where the housing prices are there. So what is our machine learning system we are going to build now? When some new value comes into the system, with this independence variable which have these features, you can so these columns I'm going to alternatively refer these columns as features as well. So please understand that these are the columns, or you can call them features as well. So we are going to use all these columns or all these features to predict the value or to regress the value of this house or particular house. So we'll start and with basic. Now we have imported data. So as you have understood or as you are aware about the EDA part or exploratory data analysis, what we have to do first, we have to understand our data. So we'll try to execute basic. Now we have our entire data set in our data. We have converted our data set into a data frame now. So this pd.read CSV will read our data set into a folder date into a variable data, and this pd is a panda data frame. Which will convert our CSV file into data. What is data.head function do? It will retrieve top 5 columns from our uh, data set from our data frame. If you remove the head, then it will, if you execute, if you want to execute particular cell, then you can use control plus enter. You can see there are 20,640 rows are there and 10 columns are there. So we'll use head for first 5 columns. Then next is we have to understand our data. What we'll do? So there is one more function is data dot information, which is data dot info. So what this function do? I'll try to comment everything so you will understand what I'm trying to do. So this function will check the data information whether is sorry data information is there any null value. Now what is null value? Null value means the columns or the rows where value is not available or value is not recorded at the time of data generating or at the time of performing this survey. So those variables, sorry, those rows are not useful for us, because one more point to notice here is that whenever you want to perform a regression, you have to understood that you are not allowed to have a null value. Otherwise, your outcome of the problem is not very. There will be a lag in your accuracy of the problem. So null values and or missing values. So once we press Control plus Enter, you'll see something like this. Okay. So longitude having 20,640, it's not null. Not null means it shouldn't be null, and its data type is float. Same as latitude here, housing, median age here, every single variable is available or every single feature is available. If you can observe in total bedroom, you can see there are 20,433 uh, rows are available. So definitely there are some values where there are some rows where value is missing in total bedroom column. So what we are going to do now? So we have understood that. So what we'll do now? We will drop those values, or we will drop all the rows where total bedroom values corresponding sorry total bedroom value is null. So we have to drop all those ones. So there is a function. So you don't have to write explicitly everything. Panda is very beautiful framework where everything is defined or everything is available in the form of function. So what you have to do? Data, which is our data frame. Now you have to drop a column. Now when you use a function only drop, then you will pass, if you pass certain column names here, for example like longitude or latitude, it will drop an entire column. So we don't want to drop entire column. We have to drop NA value, which is not null value or null value or missing value. And there is one attribute for this function in place is equal to true. So we don't have to reassign this particular data frame to data. We don't have to perform something like this. So if we pass in place is equal to true, it will directly change. It will directly make change in our original data frame. Once we execute, and let's check. What is information say now? Data dot information. If we execute this cell, now you can see the difference. Now the total number of columns or total number of rows available in every single feature is 20,433. Why? Because our total bedroom column were 20,433, and what there are some missing values. So all those rows where in total room column had missing values has been dropped from our entire data set. Now we are good to move ahead. Okay. So now we will do certain analysis or we will do certain plotting. So what we have to do, we will do a histogram. So usually when we pass or when we do a linear regression, what we have to do is we have to understand our data should be not in only linear regression. In most of the machine learning problems, our data has to be in the form of normal distribution. Normal distribution, if you understand bell curve kind of concept, and then you will understand what is normal distribution and everything. So there are certain topics that I'm which will be out of this course, out of the scope of this session, because it will take too much time. We will not able to cover everything. So now we'll plot this. Don't worry about how am I able to code everything. And you will be handy with code once you practice everything. If you want to avoid warnings, or if your rows are giving warning, you can try to put semicolons here. So you'll get something like this. You'll see the histogram of every single features or every single column available in our data set. Now you can see, if you do a little bit observation, then our longitude is partially normally distributed. Then our housing median age is also normally distributed. But if you can see our total rooms is rightly skewed. Then our total bedroom is also rightly skewed. Population is also rightly skewed. So this is not a good way. So what we have to do, we have to again perform certain pre-processing. What we can do, we can perform a certain we can do some certain logarithmic operations. So on total rooms, total bedroom, whatever features which are rightly skewed, so we can make them, we can convert it into a normally distributed data. So before that, yes. So before doing that, I'll also show you how to find a correlation. Now these 9 features are there, then how to find the correlations of these features. So there is one more, again, very simple and easy function. You just have to write data that COOR correlation. It will give some warning, but yes. Mm, yes. Okay. Now this is a correlation matrix. Now, if you can see, this is very difficult to read. We are going to plot it. So this is variable which are same. For example, if you are able to see longitude versus longitude, definitely the correlation will be 1 because they are related to each other. If you see the latitude versus longitude, the correlation is minus 0.92. So this is what I already defined what is a correlation. Uh, it is a weightage that how two features or how two columns are correlated to each other, or how that particular independent variable is correlated to a dependent variable. Now we haven't, so again, what we'll do, we'll beautify using SNS. We'll plot this entire correlation in the colorful way, so you will able to understand or you will able to read it. So what we'll do, we'll try similar 6 is equal to, let's say, 15 by and SMS. We are going to draw a heat map where data will be present in the form of color intensity. Correlation, then about it with so this is basically a color code. You can find number of color codes are available there. And if you read a SNS documentation or Seaborn documentation, so this is just an example. Anode means it is going to print values on the plot on the whatever graph or whatever plotting you are going to see now. So press Control plus Enter. I hope everybody. Okay. Okay. I'll ask everyone to share all the materials today itself. So by today, after this session, everybody will get a mail of this session
Yes, everyone
recording.
will get.
Yes, yes. I'll make sure that. Okay, we have encountered certain errors. PLT is not defined. Okay, I think while importing Fine, as NP. It was error here. This was typing. Yes, now we got it. Okay. So now, now let's see. We have already aware about the fact that what will be our outcome variable or what will be our dependent variable, which will be a median house value. Okay. Now you have to understand that what is a correlation between longitude and your median house value. If you can cross check that column, then longitude have a correlation value that is minus 0.045, which is less. Okay. Now housing median age. So age of the house definitely, if you are buying a house, if it's for 15-year old property, then definitely price will be a little bit lower compared to houses which having a less age. So it's having a correlation value which is 0.11, which is good value. It's making an impact in our outcome variable, which is median house value. Now again, there is a total bedroom. Total bedroom having a 0.05, not making a very good impact. So population 0.0, sorry, minus 0.065. Then household 0.065. So this is how you will able to read. This is the advantage of plotting everything, and this is the advantage of visualization. You in what happened in this particular matrix, you will not able to understand how the correlation should I how I'm going to read. It's not readable format. So uh, this is how you have to plot everything if you are not able to understand anything. So now we have plot and we have understood. Now what is our analysis from this entire plot? Okay, what we have understood, that there is variables or features like total rooms, which does not have a very great impact, or a total bedroom have 0.05, and population is having 0.025, and household is having 0.065. So these are not making very huge difference in a medium house value. So what we can do, and 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 also we have observed in this histogram that these are the features which were rightly skewed. What we expect, we want our data set usually in a normal distribution. Now what we'll do, we will do that thing. So I'll write a comment here. Let's use pre-processing, where as we have seen in histograms that following variables are rightly skewed. So what we are going to do now, we will perform log on them, because all the values are already new. So we can do that. We can normalize them, so they can come under the bell curve or normal distribution. So how we are going to do that? So what we have to do? So first feature, let's do with first. We have total 4 features. 4 features. Which are 4 features? One is uh, total underscore rooms. Okay, so we'll do first data, which is our data frame. From data frame, what column we want? We want total room. So total rooms. So we are going to replace the value for this particular column is equal to, now we are going to perform log. So there is a function in numpy which is np. I'm invoking numpy library as a np dot log and pass here total rooms. So it will perform log to the base 10 on every single value available in your total room columns. So total rooms and add 1. Okay. So this is how we did it for one feature. Now we are going to do it for 4 features. So let's do some copy paste. 1, 2, 3. Okay, now we just have to change the name of the variable. We have, I think, total bedroom was there. Total, let's check. Yes, I think total bedroom is there, population is there, and household. These 4 variables are right listed. Total bedrooms. Then populations, the population, and then households. Households. Total bedrooms. Okay. So now I hope everybody is with me. Okay. Now let's press Ctrl plus Enter. No error. Now let's plot a histogram again. Now here we have these 4 values were right listed. Now I hope these 4 values are somewhat comes under the normal distribution. Yes. Okay. If you can observe now, it is slightly left, but it's bearable now. All the values are almost in center, almost in normal distribution that you can see. So this is how you have to understand. So we haven't moved towards your regression or machine learning model. We are just trying to understand what is our data till now. So this is how EDA will help you, or exploratory data analysis will help you to understand the behavior of your data set. Okay. So now one more concept is there that we have to cover before moving to our linear regression model. So as you can see in your data set, we have one variable called ocean proximity. So in out of 10 variable, 9 variable have a value as a float. Okay. If you can observe here, all the 9 variable have value data type as a float. There is only one variable whose type is object. So machine learning in everything has to be mapped into numbers. So what we have to do right now is we have to cover, or we have to convert this single feature, which is ocean proximity, into numbers. Now there are certain techniques there is a terminology called categorical features. So this ocean proximity features comes under that terminology. This is a categorical features. Let's check how many unique values are there in this feature. So you'll understand the categories available in ocean proximity. Ocean proximity dot value underscore counts. So if you execute this line, you will able to see that our ocean proximity features have 1, 2, 3, 4, 5 values. Okay, the values are 1H ocean. 1H ocean means I think 1H ocean. 1H ocean means 1 hour drive from the coastal area. Then inland, it's in mid of the city. Then near ocean in nearby coastal area, near bay. Then whether the particular house is on island or not. Okay, so these are the 1, 2, 3, 4, 5 values are there. So what we can do usually what if you are not aware about the machine learning or techniques like one-hot encoding, usually what people do, they'll try to define 1H ocean as a 1, inland as a 2, near ocean as a 2, 3, and they but sometimes this certain kind of encoding or certain kind of mapping will create noise in our data set, and when our algorithm is we submit our algorithm for training, then algorithm is not able to understand, or the uh, linear regression or the algorithm is not able to build a very good relationship between dependent and independent variables due to certain mistakes. So what we are going to do, we are going to understand what is one hot encoding, and then we are going to perform one hot encoding on this particular feature. Now, so there are so many techniques are available, like one hot encoding for converting categorical features into a numerical features. We will understand those techniques as we move forward, and we will do more case studies. So what is one hot encoding now? I'll try to explain verbally first, and then I'll do here and practical. So basically, one hot encoding is a technique that we use for preprocessing to convert categorical variable into a numerical format, which can be used in a machine learning algorithm. So it's in one hot encoding, each categorical variable, your 1H ocean, inland, near ocean, will be replaced by a binary variable, where each binary variable represent a possible category of the original variable. I think we have to do some example here. So what I'll do, I'll share. Okay, now everybody, I hope everyone is able to see the screen. Uh, what we'll do now. Okay. So what is encoding? Okay. So now you have a feature, like you have a feature color, okay, which is red, green, and blue. So this is something like our ocean proximity. Okay. Now how one hot encoding, uh, how these features will be mapped into using one hot encoding. So what one hot encoding is, it will create it will create a new feature. For example, we'll name it as is red, or is green, or is uh, blue. Okay. So now if and let's say here, uh, now you understood this, and here a variable car. Okay, so there is car A, B, C. Okay, so car A having color red, so it will get a value 1 because it is, I already told you, it's a binary representation of a feature. So this particular column or this particular row where car A having the color red is 1, and other two columns will be 0. Now if car B is green, then column green will be 1 and other two column will be 0. Now call for car C, if color is blue, this will be 1 and other two 0. So this is very basic and intuitive idea of one hot encoding. So now this is what we are going to do with our ocean proximity features. So let me show you how it's done using code. So we have a feature, something in Panda, that pd.getDummies. GetDummies will help us to perform one. We don't have to perform any sort of mathematics or any sort of one hot encoding manually. It will perform one hot encoding for us now. Just we have to pass our column, that for this column we have to perform one hot encoding, which is our data, is our data frame, and which column we are going to pass, which is ocean proximity. So ocean proximity, yes. Now let's see how what is written. Okay. Okay. So as I already told you, or as we discussed, that it will create a new features like ocean, inland, island, nearby, near ocean. So these 5 features it has created, and it's created 5 features. Now for 0 column, it was nearby, so that's why it's here it's 1. For first column, it was nearby, that's why it's 1. For this column, it's inland, that's why it's 1 here. Other columns are 0. So this is what you did. Now you have created this. Now what you have to do? You have to attach this particular thing in your main data set, and you have to remove your categorical features. Now you have performed one hot encoding on this ocean proximity here, where nearby is there. Now you don't want to have categorical features in your data set. So what you have to do? You have to drop this particular column, and you have to add this entire thing in your data set. So how we can do? Simply we can join that into our, so you have to write data is equal to data dot join. Now what we are going to join? We are going to copy this and we'll join this with our data. And from our data, what we are going to, as I already told you, if you want to drop some columns, you can simply drop. You can simply use drop and you can pass a column name, which is ocean proximity. Spelling. Okay. Yes. Okay. That's correct. So this is what we do. Now let's see our results. It's getting okay. There are some errors. Let's check what is the error. Ocean proximity is not found in axis. Okay. Oh, yes, yes, yes. Always remember. So when you're dropping some column, you have to provide and one more parameter, that is axis. Okay, axis is equal to 1 means you are going to drop entire column. If I put x is equal to 0, by default the value having, by default axis value is 0 means you, when you are trying to drop some rows, then you can use x is equal to 0. If you want to drop entire column, then you have to use x is equal to 1. So this is what we put. Let's check again. Okay, let's see our data frame. Data dot head. We have to check. So let's see whether these columns are there or not. Okay. Okay, you can see here. Ocean is there, inland is there, island is there, nearby, near ocean is there. Okay. So now we have added this column. We have done this pre-processing. We have converted our this 4 variable into a normal distribution. Let's see, is there any change in correlation? So what we can do, we can simply copy again this thing, and we can plot again to check what is the difference between correlation. So if you can see here, the correlation between our feature 4, which were for one hot encoded feature, that is ocean, inland, island, and nearby, with respect to our price, which is price is here, median ocean value. So it's pretty good. For example, so for 1H ocean, the value is 0.20. It's good a value for the correlation. It's going to make an impact now. Then there is an inland, and there's an island. Island does not have a very good impact on our house pricing. Nearby is having 0.16. Near ocean is having 0.14. So it's good, and it's making some sense that we have done certain amount of pre-processing to obtain this result. So now what we can do, we have almost covered everything. What we can do, we can do some plot again. If we want to see that, if you want to visualize this entire ocean, like things which are away from coastal area, then we can we can plot this geographical area, geographical data. Geographical data we have in first two columns. If you see first two columns having a data of longitude and latitude, so we can plot this data. So we will get a basic visualization. We will get an idea of how what exactly I'm trying to say. So let's say figure. Sorry. And then this is first time we are going to use SNS. We are going to plot scatter plot where our x-axis will be latitude and our y-axis will be our longitude and our data will be our data. We will plot with respect to our target variable, which is median house value, and we can color palette. This is just a theme, so it look good, or the presentation will be good. And you can find again this multiple themes in SNS documentation. So I put everything. Let's execute this cell again. Control plus enter. Okay, beautiful. So if you can read this plot, what is showing? Let's see a legend here first. Legend is explaining here is that medium house value from 100,000, 200,000, 300,000, 400,000 to 500,000. The are red areas which depict the fact that these prices are high. Those housing prices are very high. And what you can observe, or what you can conclude from this particular graph, is that this entire zone, this entire zone is near to the coastal area. Okay, because the value of the houses are high, very high, near to the coastal area or in ocean proximity, which are very near to the ocean. So this is what you can depict from this simple graph. And every time if you are doing this, then you can, what you can do, you can uh, add one more cell, and you can, instead of code, you can mark down and what your observation or what your understanding you have about this graph. So you can write something like this. So these are markdown basic HTML commands. So observations, and in which you can write here red is most expensive. For example, you understood here that here uh, red dots in above scatter plot is uh, houses which are expen expensive and near to the ocean proximity. So this is basic. This is what your observation from this particular. So you can add certain, and if you can see, if you execute this one, you'll get certain something like this. So you can add your notes in your Jupyter notebook as well. Very similar with Google Colab as well. So now next is what? So what we have done is that we have now pre-processed, and we have done basic EDA. Next is what? Again, if you observe a correlation method, now you will able to understand how many analysis that I am getting from this simple observation, simple correlation graph only. Now what we are going to do is that we have to perform feature engineering. Now what is the feature engineering? So there are certain features here. For example, if you say total bedroom, which has a 0.053 impact on our median value. So it's not making it's not making a very huge impact on a outcome of the variable. And if you can see household is also very similar to the uh, total bedroom, which is 0.07. So what we can do? So now this is not fixed. What feature engineering is a field, or it is a terminology where you have to come up with your own logic, or you have to do a lot of experiments, that if I combine or if I add some mathematical element to a particular feature, how much impact is going to do it on my dependent variable. So we are going to do a very basic feature engineering where we will be dividing, will perform some dividation and operation, and we will create two features and we'll add those two features in our data set. So first features I'm going to create is that I'm going to find a ratio of total number of bedrooms versus total rooms. So we have total rooms in our data set and we have total number of bedrooms. So both does so total, if you can see, total rooms have a very good impact on our housing prices. So it can lift a total bedroom, or if you find a ratio, so we can find a let's see how much correlation value we can get for this particular features. For that, what we have to do, we are going to add new features in our uh, data set, which is bedroom ratio to the total number of rooms in a house. So data, we have total bedroom divided by data. We can directly perform division because all the values are in the form of float data type. Okay, what total rooms? Total rooms. So now we have total rooms, and another we had what household ratio, household rooms. So household is what is the definition of household feature? Household. What is the total number of household? A group of people residing within a home unit. Okay, this is the definition of household. So we'll see the ratio for household with respect to total number of bedrooms available. Sorry, total number of rooms available in house. So what we are going to do is house. We can say household rooms. Similarly, data, and we now have to find a ratio with respect to total rooms, data, households. I'm sorry, I forgot. Okay. I hope there is no break. Next spelling check. Yes, okay. Take it in. Now let's check again what our heat map say, our correlation matrix, what it says, like how these two features are going to make an impact on our total outcome. I just copy and paste it. Let's read correlation matrix. Now we have added two features, one is bedroom ratio, household. Now bedroom ratio with respect to our medium house pricing, good. It's minus 0.2. It's making a good impact. It's making a negative impact, but its value is very good compared to total bedroom, which is 0.05. So this was a good feature that we have generated. There is another feature is household. How much impact is making? 0.11. It is also making a good impact. So these are the two example features I have generated or I have come up with. You can do your own analysis. You can combine multiple features, whatever you want. You can do n number of experiments with the or you can do n number of experiments with the features or number of columns. You can combine them. If you think certain columns or certain rows are irrelevant for particular uh, for your outcome variable, then you can drop all those columns. So now basically we have understood most of the things for our data. Now important thing is that how we are going to build a model. Now we have come over the kind of yes, definitely. I'll share a recorded video. I'll also share this Jupyter notebook where I will add all the annotation and all the explanation of the topics that I have explained throughout this session, and you will also find comments for the particular code. Okay, and I'll also show you some technique that if you don't understand some code, then how you'll get an explanation of that particular code using ChatGPT, if you have heard about that. Uh, so okay, now we have done with our data analysis, or we have done with our EDA part. Now we have to build a model. So we are going to use a very popular framework available in the machine learning known as sklearn. You have to do what? From sklearn dot what we are going to build, what model we are learning. We are learning linear model. Sklearn dot linear model. You don't have to type every time, so you can press simply tab. It will give you a suggestion to you. From linear model, you have to import linear regression. Okay, linear regression. Now we have imported linear regression. Don't worry, now like machine learning have lots of libraries where you don't have to perform all the mathematics that we have explained, that I have explained. You don't have to write any sort of equation. All the things will be taken care by this function linear regression. Now what data we have? Now data in a single format. Now what we have to do? We have to make sure that we have to divide our data into train test format, so we can obtain how much accuracy is our data set is giving to us. So what we can do for splitting our data, we can use another functionality from sklearn, which is the model selection. Okay, I don't know the spelling now. I'll press tab, import train, again press tab. It will give a session. Yes, that's okay. Now we have x, which is our list of independent variable, or the columns consisting independent variable. Now how I'm going to build this list? So we have a data. Okay, you understood? Now we want entire data. Okay, we want entire data. Just drop one column, which is which one column? Our median house value, because that is our target column. Okay, so we cannot give that column in our training set. We are going to predict the value of the target column. Okay, so what we have to draw? Median value, sorry, value. So we house value over to parenthesis on x, because we are going to drop entire column. Okay, now this is a very normal or a very standard practice that whatever whenever you are going to mention x in your data set, sorry, x in your machine learning code, it will always be represented in the form of capital X, and your target variable will always be represented in the form of small y. So y is what? Your target variable, which is median house value. Okay, so now you can check the attribute, or you can check the dimension of this variable. For example, you can print the x dot shape, sorry, x capital. Okay, we have a 20,433 rows and 15 columns. Okay, similarly you can do with y. Okay, we have one column and 20,433 rows for y. So now we have to convert everything into we have to build x train to train our algorithm. We have to build separate. We have to divide entire data into two forms. One is train data set, one is test data set. So train data set will submit train data set while training our model, and we'll use the test data set to evaluate the performance of our model. Whatever patterns our algorithm has learned from the training data set, we'll apply those patterns on test data set and will predict the outcome of certain variables or certain or will predict the outcome of new data points. So X train, X test, Y train. This is again standard format. Y test is equal to train test split. This is the inbuilt function. Now you have to pass your X variable, you have to pass your Y variable, and there is one more attribute, that is test size. Now the test size is 0.2. So 0.2 test size, what does it mean? So your training set will if you have 100 records in your data set, so your training set, which is your X train, your X train and your X test will contain 80% of data. Okay, and your test set, which is Y test and X test, will contain 20 records, which is 20% of the data. So this is how you do a splitting of an data set. Let's enter. Okay, it's successful. Now we have already imported linear regression. Now it's time to build our model. So what we'll do? Model simply we'll do linear model is equal to initialize value to a variable. Now we have a data, we have X train, we have X test. So what we'll do? We'll try to fit. Fitting is just a feeding. It's fitting is another terminology for training. Okay. So what is the next step? What we'll do? We'll try to do linear model dot fit, means train or X train and Y train. Now X train, now our model going to understand or model going to see our X train and Y train data. Okay, so let's train. Okay, it's done. Now let's check a score for our model. How efficient or what is the accuracy score for a linear regression model? So there is another inbuilt function for scoring, which is linear model. Now if we let's say now our model has learned some certain patterns on an X train and Y train now. So now we are going to predict or we are going to test how our model is performing on our test data set. So let's identify the score for the test data set, X test, and our target variable Y test. Okay. Linear model, I forgot to mention. Enter. Okay. Now our model is 66.59% accurate, which is not good, but for first model, for first machine learning model you are trying to build, it is good. Now there are certain ways available or there are certain techniques available to improve the score of this particular model. So there are techniques like we can add a scaling factor, we can scale the variables, we can scale the variables, something like, for example, you can see these values are ranging from 41 to 21, 52, 52. Sometimes algorithms, it's hard for the algorithm to understand very different values. So scaling or normalizing values is something that it will try to represent this value in the bound of 0 to 1. So every single value will be represented as a zero between 0 to 1. So that is what scaling. So it's basically we use a standard scaler. It's basically a pre-processing technique that we use to transform a numerical feature. So they have a zero mean and variance. Means the scarcity between variables. Uh, it reduces the scarcity between the variables. For example, the values of the variable, if you can observe in this particular total rooms, it has 880 value, and another value variable have 709 and value, almost a difference of 6,000 or something. So what scaling will do? Uh, Scaling will make them in a very similar range. They won't lose their meaning, but they will only the form of representation will be changed. So how do we perform scaling? So let's check whether scaling will provide some help to us for this particular linear problem. So how we'll do scaling? So we have to import standard scaler from sklearn dot pre-processing import standard scaler. Now we will initialize the scaler. Scalar is equal to standard scaler. And what we'll do now is we'll try to do separate. So okay, we already have xtrain and strain pattern. So we'll try to scale our xtrain and our scale model is equal to linear regression. We are building second model now, which will be using scale dataset. Let's see how much difference this two model make. Okay. Then we have to scale our xtrain now. We have to only scale our we have to scale only independent variable. We don't have to scale our dependent variable, which are target variable, which in this case which we have a median house value. So for example, xtrain, how we are going to scale it? Scalar dot fit transform and we pass xtrain. So now our xtrain will be replaced with the scalar value. It will scale all the values available in this xtrain variable for us. Same will perform with xtest as well. Scalar dot fit transform xtest. Okay. Now we have performed. Now again we have fit. If you can observe here what we have done, we have fit our model now. Scale model dot fit. We have to pass our new variable. Let's rename them as let's put s so that we can understand these are the scalar values. So we have to pass xtrain underscore s here. Sorry. We have to pass xtrain underscore s, which is scalar well scaled. Now this xtrain s is scaled, and xtest underscore s. That is. So now our new model is going to get trained. Simultaneously, we'll do one thing. We'll also identify the score of the model. Scale model dot score on x test s y test. Let's see if it makes any difference. Linear regression of no attribute FIR. There is somewhere there is spelling is fit. Okay, another error. Found input will be inconsistent number of samples. So I think we have this original test. Again, there is an error. There is certain mismatch in our verifying. So, while training, we don't have to pass your testing, we have to pass while training. That was a mistake. While training. Again, I think let me not use this very confused. So I'll do one thing. Items. We have extend, we have scaled extend, we have scaled X test, we transform then scale model, either feed, X train, Y train, models 4 is X test. Oh, okay. Okay, I think there was some mismatch in variable. So as you can observe, even though we have used scaling, a standard scaler, which is another technique we use for improving accuracy or improving performance of our algorithm, we haven't seen much improvement in this particular uh, code or algorithm. Okay. So now we have, this is the basic, this is what basic linear regression. I wanted to cover the logistic regression as well. So, but I think the time is almost finished. So what I do have certain tasks that I want you guys to perform before joining the next session. So this is pretty much that we have covered linear regression. So similarly, you have to find, I hope you guys are familiar with the Kaggle data science, Kaggle website. So what you have to do, you have to find an data set for linear regression. You have to perform a similar kind of explanatory data analysis. You have to write observation. So I'll do one thing. I'll mark everything and I'll share this so you'll understand. Find, confine any data set for linear regression and perform EDA, write and observations for all the plots. Okay. And also now there are certain techniques. There is something called hyperparameter. Every algorithm have certain values. For example, this screen is visible, so I'm going to show you how you will able to understand algorithm better way. So what you have to do, scalar and linear regression. You have to Google and you will reach on the website, and this is a documentation of a scalar linear regression. So where you will find all the parameters, all the uh, uh, parameters and attributes that which we can use for this linear regression, and we can play with the values of these parameters. For example, if we change the features, we have to rank of matrix we can add, then we can fit intercept into it. So these are this with this all the values you have to play with all the values to improve the performance of our model. Now, as I already told you that I'm going to share some technique if you haven't understood. For example, sometimes what happened. So this code, for example, if you are able to see this code, it's very difficult initially because you don't have experience in this. So it's difficult to understand this, what this entire code is doing, how this entire plot is getting plotted. What you can do, basically, you can copy entire code, go to Google, search ChatGPT. Okay. Now log in or sign up with ChatGPT. So what you can do, just paste this code here. Just put this code here and press enter. It will give you an explanation of what each variable is doing. As you can read, this code uses the Python data visualization library C1 to create scatter plot latitude and longitude data from the input data, and the U parameter is set to medium house value. This will give you an entire explanation of this particular code line, and this is free of cost. You just have to sign up on that particular website. I'm going to put a link into the description as well. Also, for example, if you haven't understood what this code is doing, let's get an explanation for this. Okay, put this code here. Let's see how. Okay, again you can see it is explaining entire code line by line. So if whatever things you haven't understood throughout the session, or you can even ask any sort of definition or any sort of variable what it's doing to ChatGPT. So this will be very handy while you are learning. I think that's it for today's session. Okay. Okay. Hello, Ankita.
Yes, Uday.
Okay, so I think the session is almost covered. I wanted to cover one more algorithm, but I think time is not there, which will take another session. So that's it. I think you can share feedback link with everyone, and please try to. I'm going to share this.
Yes, you can share your feedbacks in chat box because attendance we already recorded while you registering for this session.
Okay, all these Jupyter notebooks I'm going to share with you. I'll share with you, Ankita, and you can share them.
Yes, sure.
Thank you. Thank you.
Yes, I wanted to take a moment to express my gratitude to you all for attending our recent webinar. Many thanks to our trainer, Mr. Uday Zubbe, for this wonderful session.